Let's take a look at a few examples here with logarithm as much as possible using the different rules. So in this first example, we can see here that we would want to apply the product rule. So using the product rule, we would break this down into the sum of log base b of 7x plus the log base b of 2y. Okay, and then here again we can apply the product rule because that's 7 times x. So we rewrite this as log base b of 7 plus the log base b of x. And then again, we can apply the product rule to this term as well by breaking it apart as the log base b of 2 plus the log base b of y. And then this is as expanded as we can get. Okay, let's take a look at another example. All right, so again here we would apply the product rule. So let's expand this expression. So here we would break this down to log base 10. So you don't have to write the base 10, but this would just be the log of 3 plus the log of a plus the log of b, and then plus the log of 5 plus the log of c. Okay, alrighty. You'll also see in the homework problem though, you can actually combine log of 3 and log of 5. So if I rewrite this as log of 3 plus log of 5, hopefully you can see that we can rewrite this as the log of 3 times 5. But to do this, I'm condensing. So I'm condensing a part of this expression. But again, for the sake of homework, you'll see that some questions will ask you to give possible expansions of particular problems. So here, if I combine that, that gives me the log of 15. And then you can combine. So again, I'm condensing here. So here we've expanded. And then I'm just going to combine and condense it back together down here. So then here I can put all of my variables together, log of A, B, C. Okay. All right, let's take a look at another example. So here you would want to apply, so we would apply the quotient rule. So quotient rule, and then we've got some exponents here, some powers, so we'll also apply the power rule. All right, so first of all, the quotient rule, let's break this apart as the natural log of x squared times y to the third power minus the natural log of z to the fourth power. And then here, I'm going to actually, I also have to apply the product rule. So we're going to also use the product rule here. So I'm going to break this apart as the natural log of x squared plus the natural log of y to the third power minus the natural log of z to the fourth power. And then now applying the power rule, the natural log of x squared is the same thing as 2 times the natural log of x. And the power rule is a really important rule later on when we start looking at application problems where we have exponential functions and we want to solve for the exponent. So this is where rewriting the equation into logarithmic form and using the power rule is going to help us solve those equations. So here, applying the power rule, that's the same thing as 3 times the natural log of y. And then the natural log of z to the fourth is the same thing as 4 times the natural log of z, okay? And so here, you'll see again how the power rule will help us solve problems later on in section 6.7, okay? Let's look at a few more examples. Okay, in this example here, you want to kind of rewrite this problem. So anytime you see the square root, you want to rewrite this. So this is the same thing as the log of x to the 1/2 power. So just off to the side here, just note that anytime you have the nth root of some number x raised to some m power, you would rewrite this as x to the m divided by n power. So for example, if you have the square root of x to the first, okay? So we usually don't put the 2 here when it's the square root, but you can think of that as the square root of x to the first power. We would rewrite this as x to the 1/2, where 1 is m and the square root is n, so 2 is n, okay? And we'll take a look at some more problems with the square root sign. So here we would apply the power rule. So we would take the power rule, and the log of x to the 1/2 power is the same thing as 1/2 times the log of x. Okay, let's take a look at one more example. Okay, so here notice we have the natural log of the cube root of x squared, and we want to expand this. So again, you can rewrite this as the natural log of the cube root of x squared is the same thing as the natural log of x to the 2/3 power. So using the power law, this means that that is the same thing as 2/3 times the natural log of x. Okay, all right, and we'll take a look at So here, again, we want to expand. So I would use the product rule, and I would use the power rule. So um, this, I would break it down as the natural log of, actually, so here, if we think about expanding this, this is already expanded. So I can't use the power rule here. It's already expanded. So actually, this is a problem where we cannot expand any further using any of those properties of logarithms. Okay, let's take a look at this example here. So in this example, again, we're going to expand, and this is the log base 2 of x to the 5th power. So that's the same thing. So here I have a power, so I would apply the power law. So this is the same thing as 5 times the log base 2 of x. And then the last example here, we would apply the quotient rule because I have that fraction, and then the power rule again because I've got that power, x to the 2nd power. So using the quotient rule, the natural log of 1 over x squared is the same thing as the natural log of 1 minus the natural log of x squared. And then I would rewrite this as the natural log of 1 minus, using the power rule, 2 times the natural log of x.